In a residential setting, installing a 200 amp breaker and can beside the meter as the service disconnecting means, and then running an SCR feeder to a panel located in the house necessitates the installation of a main breaker in the panel. The National Electrical Code, specifically sections 408.36, 230.71, and 230.95, dictates this requirement to ensure overcurrent protection and safety. NEC Section 408.36 addresses service equipment disconnecting means and requires a single service disconnecting means capable of disconnecting all ungrounded service conductors. This section emphasizes the need for a reliable method to de-energize the entire electrical system in a building, typically achieved through a main breaker or switch. NEC Section 230.71 focuses on the ampacity of feeder conductors. It stipulates that feeder conductors must have an ampacity not less than the maximum load current of the circuit they supply. This means the wires carrying power from the service disconnect to the distribution panel must be sized appropriately to handle the anticipated load. NEC Section 230.95 pertains to feeders with overcurrent protection at both ends, specifically in two-wire alternating current systems. It prohibits using only an overcurrent protection device at the supply end of a feeder if the output conductors have an ampacity greater than that of the supply circuit. This is a critical safety measure to prevent damage to the feeder conductors due to overcurrent conditions. The scenario you've described with the 200 amp service breaker and the SCR feeder exemplifies the need for overcurrent protection at both ends of the feeder. The SCR feeder, which runs from the 200 amp service breaker at the meter to the panel in the house, may have an ampacity greater than 200 amps, depending on the size of the conductors used in the cable. For example, if number 4 SCR cable is used, its ampacity might exceed 200 amps. In such a case, the feeder conductors require overcurrent protection at both ends. The service breaker at the meter, while providing overcurrent protection for the service entrance conductors, does not provide adequate overcurrent protection for the feeder conductors running to the house panel. The purpose of overcurrent protection is to safeguard conductors from overheating and potential fire hazards due to excessive current flow. If the feeder conductors are not properly protected at the house panel end, they could be subjected to overcurrent conditions without tripping the service breaker at the meter. To meet the requirements of NEC Sections 230.71, 230.95, and 408.36, a main breaker must be installed in the house panel to provide overcurrent protection for the SCR feeder conductors. This main breaker will trip in the event of an overcurrent condition on the feeder, protecting the conductors and preventing potential hazards. The size of the main breaker in the house panel should be coordinated with the ampacity of the SCR feeder conductors to ensure proper protection. It is crucial to consult the NEC tables and guidelines to determine the appropriate conductor size and overcurrent protection for the specific installation. It is also important to consider the load calculations for the house to ensure that the service entrance and feeder conductors are adequately sized to handle the anticipated electrical demand. A proper load calculation will help determine the minimum ampacity required for the service and feeder conductors, as well as the appropriate size for the overcurrent protection devices. Here's a more detailed breakdown of the code sections and their implications for this scenario. Firstly, NEC Section 408.36 mandates a service disconnecting means capable of disconnecting all ungrounded service conductors. This requirement aims to provide a readily accessible and reliable way to de-energize the entire electrical system for safety purposes, such as during maintenance or in the event of an emergency. The service disconnecting means is typically a main breaker or a fuse switch located at or near the point where the service conductors enter the building. Secondly, NEC Section 230.71 requires feeder conductors to have an ampacity not less than the maximum load current of the circuit. This provision ensures that the feeder conductors are adequately sized to carry the electrical load without overheating or causing voltage drop. The ampacity of a conductor is its current carrying capacity, which is determined by factors such as conductor material, size, insulation type, and ambient temperature. Thirdly, NEC Section 230.95 prohibits using only an overcurrent protection device at the supply end of a feeder if the output conductors have an ampacity greater than that of the supply circuit. This requirement is designed to prevent damage to the feeder conductors in the event of an overcurrent condition. If the feeder conductors are not properly protected at both ends, they could be subjected to excessive current flow, leading to overheating, insulation damage, and potentially a fire hazard. In the scenario you described, the SER feeder running from the 200 amp service breaker at the meter to the house panel may have an ampacity greater than 200 amps. This could occur if the SER cable contains conductors that are larger than those required for a 200 amp service. For example, number 4 SER cable may have an ampacity greater than 200 amps depending on the specific cable construction and installation conditions. If the SER feeder has an ampacity greater than 200 amps, the service breaker at the meter will not provide adequate overcurrent protection for the feeder conductors. In the event of an overcurrent condition on the feeder, a service breaker may not trip, allowing excessive current to flow through the feeder conductors. This could lead to overheating and potentially a fire hazard. To comply with NEC Sections 230.71, 230.95, and 408.36, a main breaker must be installed in the house panel to provide overcurrent protection for the SER feeder conductors. The main breaker should be sized appropriately to protect the feeder conductors from overcurrent conditions. The size of the main breaker should be coordinated with the ampacity of the SER feeder conductors, taking into account the load calculations for the house. In addition to providing overcurrent protection, the main breaker in the house panel also serves as a convenient disconnecting means for the entire house electrical system. This allows for easy de-energization of the system for maintenance or emergency purposes. It is important to note that the installation of electrical systems must comply with all applicable codes and regulations. It is always recommended to consult with a qualified electrician or electrical inspector to ensure that the installation is safe and compliant. They can help you determine the appropriate conductor sizes, overcurrent protection devices, and other electrical components for your specific installation. This will help ensure that your electrical system is safe, reliable, and compliant with all applicable codes and regulations. In summary, the NEC requires the installation of a main breaker in the house panel to provide overcurrent protection for the SER feeder running from the meter to the panel. This requirement is based on NEC Sections 230.71, 230.95, and 408.36, which mandate overcurrent protection for feeder conductors and a service disconnecting means capable of disconnecting all ungrounded service conductors. Failing to install a main breaker in the house panel could result in a violation of the NEC and could create a potential safety hazard. Therefore, it is essential to comply with the code requirements and install a main breaker in the house panel to ensure the safety and reliability of the electrical system. Remember to consult the latest edition of the NEC and any applicable local codes for the most up-to-date requirements. Electrical codes and regulations are constantly evolving to improve safety and prevent electrical hazards. Staying informed about the latest code changes is crucial for electrical professionals and anyone working with electrical systems. By following the NEC and other applicable codes, you can help ensure that electrical installations are safe, reliable, and compliant with all applicable regulations. This will protect people and property from electrical hazards and ensure the proper functioning of electrical systems. Therefore, it is always recommended to consult with a qualified electrician or electrical inspector to ensure that the installation is safe and compliant with all applicable codes and regulations. Additionally, consider these points when determining the appropriate size for the main breaker. Firstly, conduct a thorough load calculation to determine the total electrical demand of the house. This calculation should include all fixed appliances, lighting, and general use receptacles. Secondly, select a main breaker size that is large enough to handle the calculated load, but not larger than the ampacity of the SER feeder conductors. Thirdly, consider the potential for future load growth when selecting the main breaker size. It is often wise to choose a breaker that is slightly larger than the current load to accommodate future additions or changes to the electrical system. Fourthly, consult the NEC tables and guidelines for specific requirements regarding conductor ampacity and overcurrent protection. Fifthly, ensure that the main breaker is properly labeled and identified for easy identification and operation. Sixthly, have the installation inspected by a qualified electrical inspector to ensure compliance with all applicable codes and regulations. By following these guidelines, you can ensure that the main breaker in the house panel is properly sized and installed to provide adequate overcurrent protection and a safe and reliable electrical system. Remember that electrical work can be dangerous and should only be performed by qualified individuals. If you are not comfortable working with electricity, it is always best to hire a qualified electrician to perform the work. A qualified electrician has the knowledge, skills, and experience to safely and correctly install electrical systems. This will help ensure that the installation is safe, reliable, and compliant with all applicable codes and regulations. Taking these precautions can help prevent electrical hazards and protect people and property from harm. The importance of proper grounding and bonding in electrical systems cannot be overstated. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and to energize the circuit. Bonding connects all metal parts of the electrical system together, creating a low impedance path for fault current. Proper grounding and bonding help to prevent electrical shock hazards and reduce the risk of fire. They are essential for the safe and reliable operation of electrical systems. When installing a main breaker in the house panel, be sure to follow all applicable grounding and bonding requirements. This will help ensure that the electrical system is properly grounded and bonded, providing a safe and reliable electrical system. Additionally, be sure to use the proper tools and equipment when working with electricity. This will help prevent electrical shock and other injuries. Always wear appropriate personal protective equipment such as safety glasses and gloves when working with electricity. Electrical work can be dangerous and should only be performed by qualified individuals who have been properly trained and equipped. This will help ensure that the work is performed safely and correctly. Also, ensure proper torque when installing breakers and other connections. Loose connections lead to heat and fires. The NEC specifies torque requirements for various connections. Follow the manufacturer's instructions. Using a calibrated torque wrench is recommended. Regular inspection of electrical panels is a good practice. Look for signs of corrosion, loose wires, or damaged components. Address any issues promptly to prevent future problems. Consult a qualified electrician for any necessary repairs or maintenance. Over time, connections can loosen and components can degrade. Regular inspections can help identify and address potential problems before they become serious. Consider the type of loads being served by the panel. High inductive loads such as motors can cause voltage sags and other power quality issues. Using properly sized conductors and overcurrent protection can help mitigate these issues. Power quality is an important consideration for many electrical systems. Voltage sags, harmonics, and other power quality issues can damage equipment and disrupt operations. If you are experiencing power quality problems, consult a qualified electrician or power quality specialist for assistance. Surge protection is another important consideration for electrical systems. Surges can damage sensitive electronic equipment. Installing surge protective devices at the service entrance and at individual panels can help protect equipment from surges. Surge protective devices are designed to divert surge current away from sensitive equipment. They are an important part of a comprehensive electrical protection strategy. Understanding the different types of circuit breakers is helpful. Common types include standard thermal magnetic breakers, ground fault circuit interrupters, and arc fault circuit interrupters. Each type provides different levels of protection. Standard thermal magnetic breakers provide overcurrent protection. Ground fault circuit interrupters protect against ground faults. Arc fault circuit interrupters protect against arc faults. Each type of breaker is designed to protect against specific types of electrical hazards. Remember to de-energize circuits before working on them. Use a voltage tester to verify that the circuit is de-energized. Lockout-tagout procedures should be followed to prevent accidental re-energization of the circuit. The energizing circuits before working on them is essential for safety. This will prevent electrical shock and other injuries. Lockout-tagout procedures are designed to prevent accidental re-energization of circuits. They are an important part of a comprehensive safety program. If you are unsure about any aspect of electrical work, consult a qualified electrician. Electrical work can be dangerous and should only be performed by qualified individuals. A qualified electrician has the knowledge, skills, and experience to safely and correctly install electrical systems. This will help ensure that the installation is safe, reliable, and compliant with all applicable codes and regulations.